Hello, this is a standalone lesson on prime factors. Prime factors is one of those topics that is what I believe is actually quite easy marks, but it's just remembering the process. And quite a few students often say to me, oh yeah, is that the one with the tree? And I'm like, yes, that's the one. Now, to do this, you do kind of need to know what your prime numbers are. Now, I know I haven't put them on here, but there is another lesson, which is what are the prime numbers and a nice easy way to find them. So if that's something that you can't quite remember what they are, go back and sort of refresh yourself on that. So what I'm going to do here is I'm going to try and keep these sessions are quite short ones. And this is where I'm going to show an example of how to create a prime factor tree to show the prime factors of 56. And I always feel that actual worked examples tend to work better, especially when you haven't got a teacher there kind of is able to kind of adapt the learning for you. So if you're watching it, you've got a real life example to work out what we do. Okay, so first step here is we're going to start with the number 56 and allow yourself maybe half a page to do this. So if you're in your school book or what have you at the bottom of a page, don't start it there. Go to a fresh page so it allows you the time to, so what we're going to do is create a little tree underneath. So step number one is, what two numbers multiply together to give 56? Doesn't matter what those two numbers are, as long as when you multiply them together, you get 56. Now, here's a little challenge for you. What I'd like you to do is say, well, actually, do the same thing again, but maybe use two other numbers. Does it make a difference to your answer? Let me know. Okay, so this one is very much about just going through an example with you. Okay, so 8 and 7. I have my daughter behind me here. She may chirp in now and again, but I've told her she's got to be quiet. And it's good revision for her because she's actually doing her GCSE this summer. So we've got 8 and we've got 7. 7 8s are 56. So what we do then is we then say, well, which one of these are prime numbers? In fact, if neither of them are prime numbers, that's okay. But if they are, what we need to do is we need to circle one and we leave it. It's almost like the end of the branch. And what we're going to be doing, it's what we call almost like a decomposition. You're taking a number and you're splitting it out into two numbers that multiply together to give it, e.g. factors. And you're breaking it down further and further until all you have at the end is a prime number. Okay, so now, are either of them a prime number? Yes, the 7 is. So what we do is we circle it and we don't go any further down that branch. Okay, quick reminder, a prime number is a number that has only two distinct factors, i.e. those numbers have to be different. So for example, 7 has factors of 1 and 7. Obviously 1 and 7 are different. That's all the factors they have. Is 1 a prime number? Have a think, let me know. Right, so let's go on and let's start carrying on with this then. So the number 8, we have two numbers that multiply together to give 8. What numbers are you going to use? I will add at this point, using the number 1 is of no use to us because all you end up with is 1 and 8 and you've still got to break down again. So any number, as long as it's not just 8 as 1 and that number. So here we could have what, 2 and 4. So 2 and 4. So again, repeat the same process. Are either of those numbers a prime number? Well, 2 is a prime number, so that one gets circled. And then 4, is 4 a prime number? Well, 4 has factors 1, 2, and 4, so no, it's not. So we carry on. So 4, two numbers that multiply together to give 4. I've just kind of given you the answer, haven't I? 2 and 2. And straight away, I've put them down as I've circled them because we've answered that question already. So we have now done what we call a prime factor. We did decomposition. So the numbers that multiply together to give 56, my daughter's sticking a pen, I don't know what she's doing here, to give 56 are 7 times 2 times 2 times 2. If you multiply those numbers together, all the ones you've circled, they should give you the number at the top. Okay. Now, the follow on from that might be, write 56 as a product of its prime factors. Show this in index form. So what you would do is what we've just done. So we've done the prime factor, we've split it out, circled when we've got a prime number, and then we would write it as 56 equals 7 times 2 times the next one, 2 times 2. So all I've done there is highlighted them so you knew I've included them in the number on the top right. Now, that's 56 as a product of its prime factors. For the next mark, showing it in index form. Now, index means you've got powers, okay? And I've got the answer there for you. So we've got 7, there's only one 7, and we don't tend to show 7 to the power 1. We just show it as 7. And then you've got 3, lots of 2s multiplied together. It's not 3 2s because that would be 6. This is 2 times 2 times 2, which is 8. Just be careful. So 7 times 2 to the power of 3. That's where you get both of the marks for that question. Okay. Now, we can also use this technique to help find the lowest common multiple and the highest common factor. This is where I'm now going to record that lesson. And obviously, if you're watching this as standalone, go and find the link and I will show you how to use this technique to find the highest common factor and lowest common multiple, or HCF and LCM as we most commonly call them. Lovely. Thank you very much. Bye-bye.